So 6.8, number 1 is VSEPR, valence shell electron pair repulsion. If you like words, you can do that. If you like letters, you can go VSEPR. If they have the letters scrambled, I'd go half, as long as they had at least 4 of the 5 letters. So VSEPR, full point, scramble the letters. As long as you got 4 of the 5 letters, I'll go halvesy on that. But valence shell electron pair repulsion is what that stands for. Then what I had in mind for the next one was something out of linear or trigonal planar or tetrahedral. But if you said instead bent or pyramidal, I'll take them too, because those are like offshoots. Tetrahedral is like the full category. Bent and pyramidal are like a subset of tetrahedral. But hey, whatever. So, but the main 3 are linear, trigonal planar, and tetrahedral. Question about the newbies? We're going to do a bunch of dot notations, and then I'll explain what these mean when we get there. Then it's all old stuff. Attractive force that holds atoms together. Ionic transfers electrons. Covalent shares electrons. Polar is unequal sharing electrons. Nonpolar is equal sharing. Diatomic has 2 atoms. The list is ION, HF, Cl, and Br. And again, what that means is, in nature, there is no such thing as H on the loose. It's always going to find another H and become an H2. All the oxygen you breathe is O2s. You don't breathe any O's. You breathe all O2s. 13 stuff goes from 0.7 to 4, and those don't want electrons. Smaller, delta minus, and then delta plus. Coordinate bond, pair of electrons on 1 atom. Lewis structures, and then 21 I got a little bit fussier compared to yesterday. We're still going to write the electron dot formulas for all the elements. In the middle, if you say arrange these to obey the rule of 8, I'd give you half. Hydrogen wants to obey the rule of 2 for the other half. If you started with the central atom, you got, I guess, a half. If you say it's the least electronegative, you still probably only got a half, because I do want to say that hydrogen never goes in the center, and all of that, say all of that, you get your full point. Structural formula is 24, bond angle, double bond, triple bond, and polyatomic ion. Question about scoring.
21.
21, write the electron dot formulas for all the elements. Obey the rule of 8. Except hydrogen obeys the rule of 2. And you start with the central atom, which is the least electronegative, but never hydrogen. Question about scoring. Tomorrow I'm going to declare homework doing sort of day, so we'll do an ions catch-up quiz, and then do some homework. And bring me homework questions if you need them, because the chapter is not much left. So we need to understand how to do the stuff we've been encountering, especially the dot formulas. I'll do some more dot formulas to help your dot formula career, as well as to illustrate what these new words meant. The next time you'd have a quiz would then be 2 days away, which on our calendar takes us to Monday for 6.9. So Monday 6.9 is going to have 2 new points, it looks like. It's not a very long read. Nothing is in the margins or anything, so you just have to try to read and figure out what's happening here. But 2 new points off of reading 6.9. Total quiz shrinks to 25, so I must be ditching something and rearranging some other things. So let's see, compared to today's, I think I'll mark these in such a way that I don't have to figure this out ever again. keeping 4, keeping 5 to 8. 9, 10 is gone, 11, 12 is gone, 13, 14 is gone, 15, 16, 17 gone, 18 I start to keep again. From 18 to the bottom is keepsies. Compared to the top, number 1 is a keep. Someday, for extra credit, you could tell me what those words meant. What did they mean? That is correct. So if you didn't know that, jot down valence shell electron pair repulsion, and someday that's a bonus. Then 2 and 3 becomes a 3-part question, 2 points each time. Here's another side extra credit point. If you can tell me something about Coulomb's law that was in this reading. Anybody have a thought on Coulomb's law in this reading, what it was talking about? Splotch of electrons.
The shapes of those on the electrons trying to be as far away as possible.
There you go. So something about, I wrote electrons maximize the distances among all the pairs. What she said is another way to say what I said. But electrons maximize the distances among all the pairs. That's Coulomb's law. So someday for bonus, if you say Coulomb's law, it tells us that electrons maximize their distances among all the pairs, which is a fancy way of saying they stay as far away from each other as they can, because charges, same charges always repel, so they want to get away from each other. But here's the new way these 3 questions go instead of 2, 3, a little bit open-ended. I'll ask you if you have 2 electron groups in a bond, what that shape is called. That is linear. And what's the bond angle when we have linear groups? It is 180 degrees. I'll explain that once we have these dots to look at. If there's 3 electron groups in a bond, that shape is called trigonal planar. And the bond angle for those, 120 degrees. And I can explain those by math once I'm standing up and have dots to show you. If there's 4 electron groups, that's tetrahedral, and that's 109.5, and the geometry on that is not as simple. But you can just memorize it. The other 2, if you know a little bit of geometry, you don't have to memorize them, you can just logic those. But memory works as well. For extra credit, someday, there were 2 that appeared within the tetrahedral category. They're tetrahedral with something special about them. For bonus someday on those.
Like the
Bent is one, and pyramidal is the other one. Question about what's going on with any of that? So again, tomorrow, homework day. Tomorrow, most of you elected to push the IONS quiz to there, so we'll clean that up tomorrow. The next vocab quiz reading thing is 2 days away, and the Monday from where we sit into 6-9, 3 new points, a lot of today's copied, but a new creation on this linear trigonal planar tetrahedral. There is a homework. The homework's going to involve doing dots and then making a judgment about shapes as we just described. So homework on this is a 1, Y, and Z, and a 15, 16. It'll be about what it is when I stand up and do some things and we nudge the camera, I suppose. Question about life there. All right. So pH 3, who's going in the center? P. How many dots does P have? 5. How do we know? It's Roman numeral 5. And because we're building experience where you might just start to know some of these things. So if I do 5, I'm going to go single, 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 and somewhere put a double. Doesn't really matter. Then along comes hydrogen, each bring in 1. And this is pretty easy to piece it together because 1 hydrogen's going top,
Left.
left,
Bottom.
bottom, each bringing one. Does that work?
Yep.
Yep. No big issues there. It's all about that. I'll come back, we'll talk about shapes in a minute. Central on this. O. O has 6, so I might go like 1, 2, 3, 4, 5, 6.
Two hydrogens, one on each side.
One on each side,
Each bringing one.
each bringing one. Any tricks there?
No.
Nope, that one worked fine. Am I still on view here?
Yep.
Okay. So central on this
Up.
is
C.
going to be the C. Has
3? No.
4 dots because it's in column 4. So your first instinct is probably 1 on each side. O's come in. There's 3 of them, but so top,
Left, right.
left, right. O's come bringing
6.
6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6.
The one with the C could go with one of the O's.
Yeah, because we have problems right now. So
So the one electron on the left O could go.
so we'll go
Yeah.
double there, so we don't have an empty space where we don't need any more electrons.
And then we'll
That could shove that one there. How are we looking then?
good.
We still have 2 O's that have stuff, but we have extra.
We still have 2 O's that are short, but we've got
Two
2
coming in.
extras because of these wild cards. So one of those has to go on the
Top.
top and
And
one
one has to go on the right.
on the right, and we're good. H2S. S is central, count
7?
7. 1, 2, 3, 4, 5, 6.
7?
Is it a 6? Sulfur a 6? Pretty sure. Yeah, okay. Hydrogen,
One on the top, one on the bottom.
top, one on the bottom. And I don't know why I did that example, because
Each
that's
bringing one.
same as H2O, so I don't know what that was about, but that's not anything different than the ones we already had, but oh well. Central here,
C.
carbon has 4. Not a real tough decision how to do the chlorine.
One on each side.
One on each side. Each chlorine brings 7, so how'd that go?
Perfect, perfect.
Perfect. Tedious.
No, C.
Go C, central. Carbon brings 4. Sulfur brings 6.
So you gotta go one
So-
on one on each side of it and then double bond.
We're gonna have the double bond. We're not gonna have enough electrons. It doesn't make sense to have singles out here, so we're gonna go move that one, move that one.
And then
What's sulfur gonna have to do?
Double.
Double bond there. 6,
and then same thing on that
same
side.
thing. And that works. Flush them all back. So here's your words in action. I'll label these A, B, C, D, E, F. What was one of the 3 types today? Linear. Who up here is linear?
B.
B is linear, is not linear.
F.
F is linear.
Red, isn't it?
We'll come back to that. Why is this one linear and that one's not linear?
F is linear because of the 2 bonds going, they all go across
Where do we most have to look?
in the
At who?
center.
Center. We have to look at the center. How is this center different than that center?
Because the bonds go all the way across.
Well, we gotta, let's look at the definitions and stuff. What was linear about? What was the prompt in the question that you said linear tomorrow?
2 electrons groups.
2 electron groups. Trigonal planar has 3, the other ones have 4 at the center. So if we look at the center, how is this very different from that?
Because it is 4 versus 2.
Yeah, this has electrons on 2 sides. That's linear. This has electrons on all 4 sides, so that's who? That is the tetrahedral family. Who else is tetrahedral?
A and E.
A has it on all 4 sides, so that is a tetrahedral.
D.
D, we're on all 4 sides, so that's tetrahedral.
E.
E is on all 4 sides of the center one, so that is tetrahedral. What's C?
Tetris.
C is trigonal planar. Question about that identification game? Then tetrahedral had some subcases. So there were 2 subcases. One was pyramidal. Pyramidal, anybody have a guess on which of these tetrahedrals is a pyramidal?
A.
It is A. Pyramidal is going to have 3 atoms and like 1 stray pair. Are any of the other tetrahedrals pyramidal?
C.
C is, I know, that was trigonal planar. That's not in the thought. Can only, tetrahedral can be pyramidal.
No.
No. What was the other tetrahedral subshoot? Bent. Bent has 2 atoms and then 2 pairs on the loose. So
B and D.
B, this is tetrahedral, it's also bent.
D.
This is tetrahedral, also bent. And then we're good. On that game. Anyway, question on that game. Then another game they might ask is what the bond angle is. So why for geometry is it pretty easy to know these are 180 degree bond angles? It's a line. So the full loop of life is 360 degrees. Did that try to turn off?
Yeah, I have to hold it here.
Okay. So that's 360 degrees. We split it into 2 halves. That's 180. So bond angle on trigonal planar, the math is easy to do 120 because divide by 3. 360 divided by 3 is 120. No big fuss. These are 109.5s. Oof. I can't explain the geometry to you because I don't want to, and you don't want to hear it. But what's going to go on with these tetrahedrals? Did anybody pick up on what's happening to them? Like this would be a pretty accurate drawing if I go carbon, double bond, sulfurs. If I had like the balls and sticks like you see on TV when people are doing science and stuff, you've probably seen that, building atoms and molecules and whatnot. This would be a pretty good representation. You'd have a thing, you'd have a stick, you'd have a stick, you'd pack things on it and it would make a straight line. This would look more like this, where we have carbons and we've got oxygens, and it would be like this flat thing that would look about like that. Anybody know what's going on these 109.54 ones?
It's like 3-dimensional.
It's got to get 3-dimensional. So this would be like my tripod would be my best maybe example of this. We've got the 3 legs and then a 4th thing shooting out the top. So you'd have, like the camera is the central atom. And then there would be 3 bonds going like the 3 legs of the tripod trying to get away from each other in 3D space. And then pointing straight up like a 4th thing. So in terms of drawing these, the way this one would draw would be sulfur in the center. They're going to go dot, 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 dot. The dot, dot, dots indicate that that would be actually headed, theory,
Up.
behind the board. They're going to do a thing like this that make it all solid. And that's gonna be a thing that would be coming
Towards you?
towards you. And then they're gonna go regular normal line, which means that's like on the board. Make hydrogen on any of those, make hydrogen on any of those, and do some dots on the other ones, and that's what they have in mind for us to draw sometimes now. So something like this, we get a central, dot, 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 weird little triangle-y, like solid colored in thing, and one like normal line. But we've got fluorines on this, on all of them. But any of these tetrahedral ones, you go dotty dot for behind, solid for coming at you, and then a regular line, just like normal connector. If you saw those pictures in the book at all, if you noticed that as you were reading, like that's what they're talking about, that's what they're after. In the homework, let me see if they want us to draw that, or if that's more of a wait for the test moment. Let's see. Today we're on 14, says determine the shape and the bond angle. They didn't care if we drew that 3D stuff today, so that didn't matter. But 14, there's only A, B, C, D. Question about dots and 3D draws and whatnot. What do you think? Shut that on down.